All right, today we're going to do section P.2, which is titled Properties of Exponents. We talked a little bit about exponents last class period, and we're going to kind of go further down that trail today. And then we'll get a little bit, just a touch, into P.3. So P.2 will be due in my math lab on Wednesday at midnight. Okay, that's when it will be due. So first of all, we're going to take a look at some properties of exponents. Some of these you may remember, some of them you may not. That's okay. Properties of exponents. Does anybody remember what the first one equals? Like, what would I do with those exponents to write them with a single base? Yeah, it's either add or multiply. This one's actually add. So if you have the same base written to a power, and the powers could be the same or they could be different, you actually add the exponents together. Okay? So what do you think will happen if you're dividing bases that are the same with exponents? You subtract. These two kind of go hand in hand. If multiplication turns into addition of exponents, then division will turn into subtraction of exponents. Okay, now a few of you had thought the first one might be multiplication, and you were probably thinking of this rule right here, a to the m to the n. When you raise an exponent to another exponent, that's when you would multiply the exponents. So a to the mn. All right, the last two kind of go together as well, like the first two did. These feel like there's some sort of a distributive property going on. It's not really what's going on, but it feels kind of like that. The idea is that if I have AB times AB times AB a whole bunch of times, I could sort of collect all the A's at the front, and I could collect all the B's at the back, and if I counted them up, there would be M of them. So this is A to the M, B to the M, and the reason that's working is because multiplication is both associative and commutative, so you can switch the orders of things and regroup them when you're multiplying. And if multiplication raised to an exponent works that way, then so does division. So this is A to the M over B to the M. These are the 5 most basic properties that we use. There are 2 others we're going to use as well. They don't come up quite as frequently. These are really common ones, but they do crop up on occasion, one of them more than the other. So the first one here says, well, what happens when you have negative exponents? So does anybody remember how negative exponents are dealt with? Right, so it becomes a fraction. So right now, it's sort of almost like it's written over the number 1. Right? And so it's not that we put it over the fraction, we kind of almost like put it in the denominator of a fraction. So this would be equivalent to having 1 over a to the n. Now, that's because the the exponent was negative. We move it to the denominator, it becomes positive. What if it had already been in the denominator? What if I had a variable with an exponent or a number with an exponent that was negative, but it was in the denominator to start with? You would move it to the numerator. So you're going to move it to whichever place it's not. If it's in the numerator, it's going to move to the denominator, and if it's in the denominator, it's going to move to the numerator. When you make that move, the negative is eliminated. In effect, you've operated on it appropriately, okay? In general, your answers to problems will have no negative exponents. Unless they're otherwise indicating that you need to do it something different, the general rule of thumb is no negative exponents in your answer. Okay, so you're going to simplify until there's no negative exponents. 0 exponents. So this is the one where I'm actually going to explain to you why it works. But does anybody remember what anything raised to the 0 power is? 1. We've got a lot of you who remembered. That's great. I'd like to justify why that one works, because I could justify all of them and that would be fine. But this one is the one that sort of looks a little bit like magic. Really. I mean, you throw a 0 in there and all of a sudden things turn into 1s. And it really didn't even matter what A was, right? That looks a little bit funny. So I'd like to take a look with you at this expression. This is a value, a to the 5th, divided by itself, correct? All right, what happens when you divide something by itself? That's 1, right? So this is equivalent to the number 1. But we had a property over here, number 2, that said that if I have a variable or a base raised to an exponent over another base, same base, raised to an exponent, I could subtract the exponents, right? So this would also be equivalent to a to the 5th minus 5. And what's a to the 5th minus 5? It's a to the 0. So it's a very quick argument of why that's really working for us. It really is a true statement. It's not just something that some mathematician somewhere made up. Okay? All right, so we are going to use these properties, and we're going to simplify some expressions. Now, the first couple of them will depend on how the directions are worded. It may say to leave it in exponential notation, so I'll show you what the answer would look like for that. It also could say to simplify to where you have no exponents at all, and that would be okay. Now, the first thing I want us to realize is there's a negative in this problem before the 5 to the negative third. We saw something happen like that in the last section that we did together. Where's the negative? Outside in front of what's going on, right? So it doesn't get sort of involved with the exponent process. It's part of the answer, but it doesn't really get to be part of the problem you're working. It's the 5 that's raised to the negative third exponent, and that's a negative exponent. So what's going to happen to my 5? It's going to be in the denominator. So I'm going to create a fraction with a 1 in the numerator because I don't have anything else to put there, like there's no other values. And I'm going to have a 5 to the third in the denominator. Okay, so it's quite possible that your problem will say leave it in exponential form and you would stop here, okay? It's also quite possible that it would want or expect for you to simplify the 5 to the third because, I mean, you can, right? It's not like it's a variable to the third. So what is 5 to the third? It's 125. So this expression is also equal to negative 1 over 125. And if you aren't sure which one it is, I mean, I'll be careful and clear in my directions on quizzes and on tests and so forth. But if you aren't sure in my math lab or you're just moving quickly, you aren't paying attention, and you put 1 in and it, gives you back an error and says you got it wrong, you have another attempt. So you just fix it and you put it in correctly and kind of make a mental note that I need to be more careful about the directions, that kind of stuff, okay? All right, let's take a look at the second one. This one starts out with 6 to the negative 1. So how are we going to rewrite that without the negative exponent? 1 over 6, right? And if you want to write 6 to the power 1 in the denominator, you can, but 6 to the 1 is just 6. What about the 5 to the 0? Plus 1. Now, there's a couple of things you could do. Any suggestion? What could I do to get my final answer to combine these? Okay, so we could do one of them as 6 over 6. Rewrite the number 1 so that they have a common denominator, right? We could do that. If we did, we can add our numerators together, and what would we get? 7 over 6. What kind of a number is this called? Improper fraction. Good job. So this is an improper fraction. Mathematicians really like improper fractions. I'm not really sure on the why. I think it's because it's easier to work with if you continue with the problem, in some other sense later. There may be another way that you could write this. Did anybody else have a different thought? What'd you think of? You could write it as a mixed number, and mixed numbers are also appropriate. And depending on the context, they may be more appropriate. So you think about like an application problem and a word problem. If somebody asks you, if I have 1 cookie and you have 1/6 of a cookie, how many cookies do you have? You're probably not going to say 7/6 of a cookie, right? No, you're probably going to say 1 1/6 cookie. I mean, so there are times when mixed numbers are far more appropriate. So another possibility would be to write it as 1 1/6. And again, it'll depend on how the problem is given to you as to what the expectation is. There are cases as well, even in my math lab, where they would accept both answers as perfectly correct, okay? So one of those two. All right, number 3 looks quite different because we actually have variables in number 3, and we didn't have variables in 1 and 2. So taking a look at this one, what I'd like for you to recognize is from moving from left to right that yes, there are parentheses, but really, Do they need to be there? Not really, because all they're doing is indicating that this is just all multiplied together, right? So multiplication, as I mentioned when we were talking about the properties, is commutative and associative. Commutative means I can switch the order of things, right? So like I could switch the b to the fourth with the 3. I could just flip them. I could flip them around, right? It also means that I could take the parentheses out and I could put the parentheses in a different location. That's associative, okay? So those two properties combined mean that I am able to take what's written here and to regroup it and put the like items together. So I'm going to take a step to actually do that. If you don't need this step, that's fine. Just ignore it. Don't write it down even, or whatever you prefer. But basically, I am allowed to regroup and put the numbers together, to put the A's together, and to put the B's together, whether I write it down or whether I do so in my head. I'm allowed to do that. And then I'm allowed to actually combine the things that can be combined. In particular, what's negative 6 times 3? Negative 18. And then we have our properties of exponents showing up. I have a to the 7th times a to the 3rd, a to the 10th. And then I have b to the 4th times b to the 5th, b to the 9th. And because the exponents are positive, I'm done. Okay? Again, you don't have to do that in-between step that I showed. That's fine. But the reason that's happening is because of our properties from last time. All right, we have a few more that we're going to take a look at. Number 4 has a lot of negatives going on, doesn't it? Really, it does. So let's take a look here. Are there any negatives that we can simplify right off the bat? Say that again.
The negative one, the negative 1 in front of the p. And
Yeah.
the negative 3.
Very good. So she's noticing the negatives that are sort of at the beginning, these right here. And I agree. They're both negative. What happens when you divide a negative by a negative? You get a positive, right? They cancel one another out. So even though they're there, we can just simply change them right now, right? We don't have to keep working with them and keep them, allowing them to sort of be a mess. So the very first thing I'm going to do is make those positives. Now there's a couple of things that we could do. One thing we could do is that everything that has a negative exponent simply moves locations. That's one option. The second option that we could do is that we could use property number 2 here, where if I've got a p on top and a p on bottom, I subtract the exponents. That's another option, okay? So I'm going to do the first option on this one because I'm going to do the second option on another one later so you can see it, all right? But let's take a look. Anything that has a negative exponent, according to property number 4, I can move its location and make it a positive exponent, right? Okay, now be careful. What's going to happen to the 3 at the beginning? It's going to stay put because does it have an exponent that's negative? No, so don't move it, all right? Leave it alone. So the 3 is going to stay right there, not going to move it. Now, there's another value that's going to stay put where it is. What is it? Which p? The p that's in the denominator already. So these two items have positive exponents. They don't move. Everything else has a negative exponent. So the p to the negative 1 in the numerator will become p or p to the 1 in the denominator. The q to the negative 1 in the numerator will become a q in the denominator, or a q to the 1 if you prefer. And then the q to the negative 3 in the denominator will become a q to the 3rd in the numerator. So at least at this point, whoops, trying to erase that. At least at this point, they're all positive exponents. That's a step ahead of where we were. Okay, that's good news. There's some that can be combined though. How do I know that I'm not done in this problem right now? There are 2 p's, there are 2 q's. If I were done, I would only have each variable written down one time, right? That's how I know. So let's deal with the p's first. The 3 is going to stay. What do I do for p? P to the 2nd, and where will it be? In the denominator. Good. Okay, so the p's are now combined. They're only written once. They're good. What about the q's? All right, so you can do it, and I heard both ways of thinking about it. That's awesome. So one option is to think about it as cancellation. I've got 3 q's on top, I've got 1 q on the bottom, so one of the q's cancels. The other way to think about it is subtraction. I've got 3 q's on top, I've got 1 q in the denominator, 3 minus 1 is 2. Right? Either of the options lead you to the same conclusion, which is that you have 2 q's left on top, or q squared, more specifically, left on top. And at that point, all my exponents are positive. Every variable is only written one time. I'm done. Look okay? All right. Number 5. Wow, what a mess. There's a couple of things that make this kind of ugly and messy. One of them is that I have division and I have the exponent on the outside. But beyond that, the thing that makes this sort of messy is that, do you see that the addition and subtraction is actually happening within the exponents? Right? That looks really different. This is the only one that I have where I have the addition and subtraction going on inside of the exponent. So I'm going to suggest that we deal with the inside and clean it all up first, and then deal with the -4 afterwards. If you wanted to, you could distribute the -4 through first, and that would be okay. It wouldn't hurt anything. But I think it probably is a little bit cleaner to do the inside first. Are you guys good with that? All right, let's try it. So I've got a fraction, right? I've got a numerator and denominator, so this is the quotient rule. Back over here, number 2. So it'll be the top exponent minus the bottom exponent exactly. So we have the same base, it's x. And we have our top exponent, which was 2a minus 3, minus the bottom exponent, which is -4a plus 1. Now I want you to notice a couple of things. First, the denominator's exponent, -4a plus 1, I put it in parentheses. And I did that on purpose because I want to make sure that we remember that this subtraction applies to everything inside there. Okay? It's really easy to forget the negative applying to both pieces. Second thing, notice I put parentheses around this. Why? I still need to put the -4 on there. So please don't do sort of partial steps along the way. As you're working mathematics, each step you write down should be equal to the step that follows. Okay? So as I'm writing these down, I'm not going to just leave pieces off, because the chances are, whether it's on this problem or some other problem, if I'm leaving pieces off and then thinking I'm going to put them in later, I'm going to forget them at some point. Okay? It's easier to just keep them on there until I actually do them, and that way I don't forget them. All right, let's do this subtraction. So notice I've got subtraction of a set of parentheses. So what do I need to do first? Distribute, right? I got to distribute the negative, and I am going to be just a little bit lazy as I'm distributing this negative and not rewrite it. So this would be a +4a and a -1. You guys good with that? Distributed my negative. So I have 2a and 4a, which gives me 6a. And then I have -3 and -1, which gives me -4. And all of that is raised to the power -4. Yes. Now you're ready for property number 3, the first property number 3. We're going to multiply the exponents together. So we're going to get x to the 6a times -4. What would that be? -24a. And then -4 times -4, +16. So it'd be +16 at the end. Now, you might be looking at that and saying, well, how do I know if I'm actually done? I mean, there's a negative in that exponent, right? There is. So how do I know that I don't need to put it in the denominator?
Because it applies to the whole equation at the top?
Partly, but not exactly. It has more to do with the fact that there's a variable in the exponent. Do you see that a there? Depending on what a is will depend on whether that exponent's negative. What if a is 0? It's 16, right? But if a were 1, what would it be? -8. It would be -8. Yeah, it's okay. It would be negative. So if a is 0, the whole exponent's positive. If a is 1, the exponent's negative. It just depends on what a is. And we have no way of knowing because it's actually a variable, right? So there isn't any reason to say I absolutely have to put it in the denominator because there isn't any reason to know or to be for sure that the exponent's negative. The only reason we put it in the denominator is if we know that the exponent's negative, and we don't have that fact here. So this is sufficient, and it's fine just like it is. You also, if you were looking like maybe at the back of the book, or if it was looking at a solution or something, they might switch this around and write this as 16 minus 24a. Would that be okay? Yeah, it'd be the same thing, right? So just be aware if you were trying to compare your answer to someone else's, just changing the orders of addition or something like that's no big deal. All right, let's try another one. I want to show you another way to do this. We could do this much like the one we just, or well, much like actually number 4 over here, but I want to show you another way of doing the problem, okay? I alluded to the fact I was going to do this a minute ago. So write this down, and I'm going to show you an alternate option. Okay. What I'm going to deal with first on this one is the -2 on the outside. In particular, I'm going to deal with the negative part of it, not even the 2. I'm going to deal with the negative part of it, okay? We mentioned back when we talked about those properties that when you have a negative exponent, it moves things, right? If it was the numerator, it moves the denominator moves it to the numerator. Well, if you have a negative applied to an entire fraction, you can actually just take the fraction and flip it upside down completely. So I'm going to rewrite this one exactly like it is, but flipped. In particular, the 18x squared y to the 8th will be on top, and the 15x to the -2 y to the 9th will be on bottom. There's still a negative in front, okay? That is in front of the fraction, but inside the parentheses. And what I have this now equivalent to is a +2 on the outside. So in some sense, all I really dealt with was the negative, and that's it. Okay? All right. We could distribute the 2 through next, or we can simplify and clean up what's in the inside next, and that's going to be my suggestion. So we're going to simplify the inside first, and then we'll talk about the 2 after that. All right, so taking a look at this sort of piece by piece, we have coefficients at the front, 18 and 15. Do they simplify? They do. What are they both divisible by? 3. Yeah, they're both divisible by 3, and so they simplify to 6 and 5. You're right. So this will be a 6, and this one will be a 5. Now the negative is still at the front, so I'm going to rewrite that. 6 on top, 5 on bottom. Now, I actually didn't have cause, if you will, to write this down before. We had a little bit more, well, what we did is we moved exponents like negatives up and so forth. But another way of doing it besides moving the numbers around is we could actually apply the exponent rules, which says that if I have an exponent on the top, I can subtract the exponent on the bottom. And that's another way of handling it. You can move the x to the -2 from the denominator up in the numerator and do it that way. It's fine. It's not going to hurt anything. But this is another way to think about it. Subtract the exponents. Do the same thing with the y's. This is y to the 8th minus 9. All of this is raised to the power 2, by the way. Don't lose the 2. We still haven't dealt with it. All right, so now simplifying what's here. What do I have x to the power of? 4. And y? -1. Okay? Still squared. All right, you ready? Okay, let's go ahead and put the x on the top then and the y on the bottom, because that's where the exponents indicate that they're supposed to go. So I should have a -6x to the 4th over 5y raised to the power 2. We're super close to done on this one now. Power 2. It has to apply to every single piece that's inside those parentheses. So the first thing it has to apply to is the negative at the beginning. So in other words, you're duplicating it, right? That's what squaring means. It means multiply it by itself. What is negative times a negative? It's positive. So as I move this squared through this parentheses, this negative is going to be eliminated. All right, next piece is the 6. What's that going to become? 36. Sometimes it's easy to forget that it'll apply to the numbers that are there. We get so caught up with the variables we forget about the numbers, but it applies to the 6. Okay, how about the x to the 4th? X to the 8th, good. We multiply the exponents together. Now we have it to apply to the 5. 25. And then the y? Y squared. And again, the reason the negative is no longer there is because a negative times a negative, which is what squaring does, right? Multiply it by itself, would be a positive value. All right, any questions on that one? We're going to shift gears just slightly. Like 80% of you in this classroom are intending to go into some kind of scientific field because you're going into nursing. Scientific notation is something that will come up again and again in your field. And then for many of you also, if you're doing anything else with science, scientific notation is super important. So there's a piece of this that I need to write in for you. Scientific notation looks like the following. It is a times 10 to the n. This tells you that the n is an integer, but also the a value, well, the absolute value of it anyway, the numerical component, is between 1 and 10. Typically, it's a 1 digit, right? Because it's 1 to 10, not a bigger digit than 10. But 10 itself could be included if you happen to have the number 10 itself going on. All right, there is more than one way to think about how to convert between scientific and standard notation. If you have a way that feels comfortable and easy for you to remember and you don't like my method, that's fine. Use what works for you, okay? As long as you're getting the right answer, you're good to go, okay? I'm going to teach you a way that I have found to be quite useful. I don't like talking about moving decimals left and right, because it works one direction when you go scientific to standard, and you have to reverse it when you go from standard to scientific. And I don't like having to do the reverse. So this is how I think about scientific and standard notation. Your n value, whoops, let me use black. Your n value is either going to be a positive number or a negative number. Agreed? Technically, it could be 0, but if you have n is 0, then it's 10 to the 0 at the end, you get a 1, and it's just unhelpful altogether. It just doesn't happen often. It's useless almost. All right, so it's going to be positive or negative. If you have a positive exponent, what that means is that you have a large number. And if you have a negative exponent, you have a small number. Positive exponent, large number, negative exponent, small number. So let me show you how that works. Number 7 has the number 5.98 times 10 to the 5th, and we're trying to turn it into standard notation. Now, the exponent, is it positive or negative? Positive. So the exponent being positive means that the number is going to be large. And large simply means bigger than it currently looks. Right now, it looks like 5.98. So for it to be bigger, where would the decimal go? It would go to the right. So, and how many places to the right do you think? 5, because the exponent's a 5. So right now I have 598, and I've got a bunch of zeros, and if I have extras and I don't need, I'll move them. But right now the decimal is here, and I need to move it 5 to the right. So this is 1, 2, 3, 4, 5. This is where it's going to be. So the answer I actually have is 598, followed by 3 zeros, and then the comma would go between them. 598,000. How about the second one, number 8? That exponent, what is it? Negative. So the number will be small, or at least smaller than what it currently is, which means the decimal would have to move left. So from where I am, right now I have 5.98. I'm going to have to move a decimal left. So it's going to move, this way. We're going to move it 2 times because it said squared, right? It said negative 2 is my exponent, so here's my location. You can either write this as a decimal point, 0.598, or if that bothers you, you can put the 0 before it as well. Mathematically, they're identical expressions, and my math lab won't care, and I certainly don't care. So either one, whichever you like. Okay? Okay, that's moving from scientific to standard, and so now we're going to move from standard to scientific. So taking a look at the standard to scientific, take a look back over here at the value A. The value A is supposed to be a number basically between 1 and 10, right? So looking at the numbers here, I have 16,587,000. Where would the decimal place need to be in order for the digit that I'm expressing to be between 1 and 10? Between the 1 and the 6. So the decimal point should be right here. So I've got 1.6587 times 10 to some power. How do I figure out what power it should be? Right, I need to count from where the decimal point originally was, but there wasn't an original decimal point. So what do I do now? Yeah, I need to count from the end. So it was understood, if you will, to be here, right? Yeah. So there's 3, 6, 7. That's 7 locations that I moved it. And it says 10 to the 7th. Is it a positive 7 or a negative 7? Positive. Why? It's a big number, right? It's positive because it was a big number. All right, the other one over here. Oh my goodness, there's so many zeros on here. All right, we need to figure out where our decimal point will be. Where's our decimal point going to go? Between the 9 and the 8. So I'm going to get 9.81 times 10 to something. Let's see how many decimals we've got. There's a lot of them. 3, 6. There are 6 zeros, right, that I just counted through. And then one more decimal place move. So that was 7. 7 positive or 7 negative? Negative. Why? Because it's a small number. So you guys with me on the small number, big number kind of idea? Cool. All right, number 11. Number 11 is fantastic. Number 11 is simplifying scientific notation, but thinking about it in terms of exponents, right? This is actually exponent rules. Now, it's all multiplication on top, and it's all multiplication on bottom, which means, much like the problem over here, I can simplify them piecewise as appropriate. So in particular, if I take a look at the 9.3 and the 3.1, I could divide those from the get-go. And what would you get if you did? You get a 3. And where is the 3 going to go? On the top. Now let's say that you had the numbers flipped upside down. Let's say that the 3.1 were on top and then the 9.3 were on bottom. What would you have? You'd have a 3 on the bottom, right? Which looks an awful lot like the number 1/3, which is not something that's between 1 and 10, right? So let me talk in a minute about what you would do in that scenario. But in this particular one, we really do end up with a 3 on top. Not only that, but we can use properties of exponents. This is a 12, right? 10 to the 12th. This is 10 to the negative 5th. We can subtract exponents, yeah? So this is 12, and then we do minus negative 5. So minus negative 5 is the same thing as plus 5. And 12 plus 5 would be 17. So the answer in scientific notation to this question would be 3 times 10 to the 17th. So pause with me for a moment and just pretend that we had ended up with a 1/3 here instead, times 10 to the 17th. 1/3 as a decimal is approximately what? 0.3 repeating. So as a decimal, and I'm not going to worry about the repeating part because that's not really the point of this particular question. The point of what I want to show you is that the answer right now is not in scientific notation. Do you see that? It just isn't. We would actually have to move the decimal point in order for it to be in scientific notation, and we would have to move it 1 to the right. So the answer would still be a 3, but it wouldn't be 3 times 10 to the 17th. What would I have to do to the 17? It would be 16. Why would it be, say, 16 and not 18? Because I should have made the number smaller because the number was small to begin with, right? This is a small number, So it would be a negative exponent, and if I put another negative, like a -1, because it moves the decimal one place, onto the 17, I'd get 16. Okay? So make sure that if it's asking for your answer in scientific notation, that you really are giving an answer in scientific notation, not just a simplified exponential version of it.